Hello and welcome back to our series on network documentation for newbies. My name is Kenneth and let's get started. So today we're going to be talking about how to create a basic network diagram. I'm going to be going through the slides to explain to you what network diagrams are and how they are important and how to start building out your network diagram. Then after that, we'll quickly go into how to build out your network diagram using certain tools that you might have in your environment. So in creating a basic network diagram for your network, we have to consider a few things and we're going to see those things in our slide. So as we see on the screen, creating a basic network diagram, one diagram to rule them all, right? So we're going to go to the first slide and we're going to look at why network diagrams. Now, seeing is believing, right? It's very important to have a network diagram. It helps you with faster troubleshooting, so you know where your problem is located in your network. Another one is easier onboarding. If you're onboarding junior tech, just like we've discussed before, you can, using your network diagram, show them the scope of their responsibility, right? And then we have compliance requirements. We've discussed this as well. And then we have clear communication with vendors and auditors, right? So these are very important. These are just a few examples of why network diagrams are important. There's so much more. So let's go over to our next slide. In our next slide, when you're creating your network diagram, it depends on what kind of network you are currently on. If you're on a greenfield deployment where it's new, it's brand new or being deployed while you're still there, you're there when it's being deployed, or it's a very new network, then there's a different approach to this. If it's a brownfield network, then there's also a different approach. So you need to ask relevant questions, right? If it's a greenfield or if it's a brownfield. If it's a greenfield, obviously you'll be there while the network is being deployed. So you would be able to make up or come up with the network diagram as you're being deployed, as it's being deployed rather. So while the network is being deployed, you can come up with the network diagram and make as much documentation as you need to make. If it's a brownfield deployment, it's a little bit different because you might not have been there when this network was deployed. You might just have been employed and told, we need to document our network, get on it, right? So it's different. If it's on a brownfield network, you need to ask very important questions like, one, what devices exist in the network. So you should have a fair idea of what devices are in the network. You should be able to do this by inspecting your various distribution facilities, your server rooms, and all of that to find out what devices are in the network. Where are they located? Where are the devices located, right? And what are their roles? What are the roles of these devices? Next one is, how are these devices physically connected, right? Are they by copper cable? Are they connected by fiber? Are they wirelessly connected? Uh, right? How are these devices connected? Are you having a site to site? Are you having a list line, a VPN tunnel over the internet? How are devices connected, right? Next one is, what are the IP addresses that exist? What are the VLANs? What are the subnets in use? Then the next important question is, what connections exist to external networks? Very important. You need to know how you connect to outside of your company, to the outside world, right? To the internet, to remote offices, to branch offices. How are you connected? Via list lines? Are you using VPNs? Are you using whatever it is that you're using, right? You need to understand these things, right? So these are some of the questions, not everything, right? Then the next thing we're going to be looking at is choosing a tool. There are numerous tools out there that you can use to document uh, your network diagram or come up with a network diagram. A few of them are automatic, whereby you can scan and it comes up with a network diagram for you. I think we all know that automatic scanning devices are not as accurate as we would want them to be sometimes, right? So it's important, even if you have automatic devices, when you've completed the scan and you've gotten the diagram, you should inspect and ensure that your diagram is actually what exists in the physical environment, right? Yeah, that is very important. Then manual tools, like you should have manual tools that you can use to draw, UI UX tools that you can use to come up with your network topology, right? Now, another thing that determines the tool you use is the size of the network. Obviously, if you're documenting a large network like a data center kind of deployment, yeah, a very large enterprise network, then obviously you might not, uh, manual tools might not be the best. You might need to use automatic tools and complement it with some manual effort, right? Now you can use, for manual tools, you can use things like draw.io, which is very popular for coming up with diagrams. There's Lucid Chart as well, which we all know. There's Visio, and there's Packet Tracer. Packet Tracer is not a diagramming tool, but it's more than a diagramming tool. It can do more stuff than a diagramming tool. That is why I would most times prefer to use Packet Tracer to document a small to medium sized network, because it basically has everything you're looking for in there, and you can do small configurations just to test right in there before you deploy anything, right? So Packet Tracer is one of them, and that's one of the tools we'll be using today to come up with our diagram. Now, gathering your data. Data is important when you're documenting a diagram or coming up with a network diagram, right? You have to know what IP addresses exist, right? Next thing is you have to know what devices exist in the network. Another thing is you have to know what physical connections are there. And then, obviously, things like VLAN, subnets, you also have to know that as well. Now, we have basic layouts that you can have, right? You would have core devices typically at the top or in the middle, right? Core devices like, your core routers, your core switches at the top or in the middle. Then you have your WAN devices or your WAN connections, could also be at the top or towards the left or the right. Yeah, you can have them at the top just to signify that they are WAN or external devices. Then you have other devices that you can have within your network, right? You should ensure that you have other devices like your layer 2 devices, your access layer devices, your endpoints, and all of that. Place them in the right locations towards the bottom and group them accordingly. Now you need to ensure that you have your device names as well labeled in your diagram, your device locations, where are these devices located. Management IP of these devices should be in the diagram, very important. Another one is VLAN IDs, VLANs that exist, uh, link types, type of links like uplinks and internet links and things like that, right? You should also label them. Shapes for different devices. Use industry standard shapes. Routers are typically round with the arrows that are facing in and out. Switches are usually rectangular or square with the arrows facing left and right. So use industry standard depictions of the devices in your environment. Another one is color coding for clarity. So you can color code various things, cables, floors, indicators. There are so many things that you can color code to make your diagram uh, clear and understandable. Another one is avoid messy spaghetti diagram. So avoid cables that are running here and there that are confusing, right? It makes the diagram messy. Now, we're going to take a look at how to store and manage access to your diagrams. So typically store in a central location that is accessible by the people that need it and that are permitted to edit that diagram. This is very, very important, right? If your diagram is just stored in your personal drive, someone else comes tomorrow and makes up their own diagram, and someone else comes tomorrow and makes up their own diagram, you don't know what is consistent anymore, right? You need to store it in a central location where those who have the rights to modify it can access the diagram, because a network diagram is not a static document, it's a living document. It changes from time to time. As the network grows, you add or remove stuff, right? Uh, End of life devices are removed from the network and are replaced. You modify them on the diagram as well. Links come up, links go down. You get new locations, new new floors, new buildings, you add all of those to the diagram. So it's a living document as well. Um, if you're going to share them, you can obviously create a link. A link would help so that when it's modified, whoever has the diagram sees the latest version of the diagram. If you're going to have a one-off use for them, then you can export to things like a PDF or to image or whatever to send to where it's needed. And always ensure it remains updated, it's editable, and those who have the right to edit it have access. And that's it basically. Then you need to start simple when you're doing your network diagram. Don't try to put in everything at the same time. Start simple and scale. Now we're going to take a look at how to make the diagrams next, right? So we're going to be using Packet Tracer to come up with our diagram. We're going to be assuming a lot of things. Now we're going to assume that we have a network, a brownfield deployment where we have about 4 or 5 floors that we need to document the network, right? So we have a ground floor, we have a first floor, second floor, third floor, and a fourth floor. And then on each floor, we're going to assume that we have the various network devices on these floors. So typically what we talked about is it's important to ask the correct questions, right? So if you're documenting such a network, find out where these devices are located, and you have to physically go to these locations to ensure that these devices are actually in those locations, right? Because if it's your task to document, you have to double check and you have to ensure that these devices are actually where they say they are. Now, if we are to assume that we have a 5 floor, right? And we our assumption is that we have 2 switches on each floor, right? So we're going to take a look and we'll say we have 2 switches on each floor, just like this, right? So start small. You go to these locations, you find out that there are 2 switches on the ground floor, right? You don't have to see what all the connections are. Just find out what the switches are, what model of the switch are in these locations, and you can put them, start your diagram by putting these switches on there, right? Inspect the floor and ensure that you know what kind of devices exist on the floor. So typically in a building where we have a network infrastructure, obviously you would have computers, right? You'd have maybe desktops, you would have laptops. Probably if it's we have mobile workers as well. You would obviously have some wireless LAN controllers in the on the floors. So to get wireless LAN controllers, we would go here and get some access points, right? So we have some wireless access points, probably for those using mobile phones, tablets, and laptops who are walking around here. So we have these devices there. And then probably if you're working if it's a secure place, you typically have CCTV cameras, right? So you'd have CCTV cameras also lying around. Now you don't need to bring in every single device or the amount or the quantity of devices that exist in that location. Let's say it has 24 cameras, then you have to put 24 cameras here. No, it doesn't work that way, right? You don't need to put all the individual devices that are there. Let's say you have 20 desktop computers, then you bring in 20 desktop computers. No, it's not necessary to bring in every single device, but the main devices here are these static devices that are in your IDF, right? Your intermediate distribution facility. This is your small telecommunication cabinet that could be in the floors. Let's say you have a 12U rack or a very small rack in on each floor that has these devices, a switch, and then obviously cameras in various parts of the floor, and then you have 3 or 4 access points littered here and there, right? So you don't have to bring in every single device, right? So what you need to bring in are the main devices, the 2 switches. These 2 switches are fine, right? Now after that, let's assume that all these devices are connected, right? So I'll just do a quick connection. So a quick connection, right? And let's say that these switches are stacked, right? So that they have connectivity over, they have VLANs running on them, and then they have trunk ports connecting them, right? And let's say that this is our first floor, right? So you can label or tag this any way you want to tag it. So, sorry, our ground floor, right? So let's say that this is our ground floor. Now that we've said that this is our ground floor, next thing we need to do is go to the next floor, right? Let's say that what we have on this first floor is similar to what we have on the ground floor. And what we have on the third floor, on the second floor, similar, third floor, and fourth floor, right? So leave it at that for now, right? So you've gone to these floors and you see that each floor has two switches that are stacked and has multiple devices connected on it, right? Now that you have all of this, this is a very good beginning. You're at a very good place here. Now, when you've done this and you've identified all these devices that are connected here, this is our ground floor, obviously, and then we would have our first, second, third floor. Now that this is set up and we have our floors marked in this manner, next thing that we need to do is check out where are these floors getting connectivity from, right? Let's assume that our main distribution facility is also on the first floor, right? So our main distribution facility is also on the first floor. So I'll just take one of these switches and we'll start off in our main distribution facility. Now, when you get to your main distribution facility, you need to take an inventory of the devices that are there and how they connect, right? So let's just start small. Let's say we have two switches on our two distribution switches on our first floor. Now, let's say this is the first floor where we have staff working, and this is a separate room where we have our, IT equipment, our routers, our switches, the server room that has the air conditioning and all of that in a separate part of the first floor, right? Now we have this, and then obviously we're going to have some sort of gateway device, right? So let's say we have an integrated services device here, and let's say something like a next generation firewall router that has intrusion prevention, uh, antivirus, routing, all those, fancy things that we need in our network running on it. So this is an integrated service device right here, right? That interfaces with the internet. Now we have all of that. Now, obviously, we're going to have some sort of service that we are using within our network. So we're going to have our servers somewhere also in that same um, uh, MDF, right? So let's say we have three servers that are having various services running in them. Let's say we have a couple of HTTP servers, data servers, file servers, and things like that running on premise in our organization, right? Now, after we've identified that these servers are there, right? You don't need to know how they connect yet. Just identify the devices that you've seen, right? Identify the devices that you've seen. So you've seen that there are three servers there. There are two switches in there, and then there's a gateway device. Probably we also have a network video recorder, which is for the cameras, right? So I don't know if we have that device in Cisco Packet Tracer, but we can use one of the switches to represent as an NVR, right? So let's say this is an NVR for instance, right? So I'll just label it immediately so it's not confusing. So this is our NVR, right? So we have NVR right there. Now, after you've identified all the devices, right, we'll typically have a switch connecting to our servers. Now, after you've identified all the devices that you've seen in the room, next thing is to trace some cabling or ask important questions about how are these devices connected? How can you show me the cables that are connecting from such place to such place? Can I see how they are connected? Obviously. So inspecting this, you will obviously see, or they will obviously tell you, okay, this device connects to this device, this connects to this device, and then from there you start making the connections, right? So would say, let's assume that your servers are connected to your switches, are just connected to the switch, and this maps some sort of DMZ within your network, right? So you have this. So the servers are connected to this switch, and the switch in turn is connected to your gateway device on a DMZ, right? And then you have your gateway device also connecting to the distribution switches, right? So you'd have this, and you would have this as well, right? Now that you've connected these devices, you're also going to ask another question. Now, how are we getting internet into our environment? Obviously, they will tell you, okay, we have 3 service providers, we have 4 service providers, and their devices are located here as well, right? You don't need to document the devices. Now, it's up to you. You can put it in this diagram or not. So you can document it's actually very important as well. You can put in the devices of the service provider, the device the service provider has brought to your location, but in this diagram we're not going to be putting that. So let's say the service provider has their own router here, which they've used to supply you internet, right? But you can represent that with a cloud. You don't need to put in the name because they have their own responsibility to document their devices, right? So what you need to do is come here and find something to represent the internet, right? So let's say you have 2 internet connections, right? We're going to name it shortly. Coming in here, and one more redundant internet link coming in here as well. So let's say you have 2 internet connections, right? Coming in these 2 places. So, and that's it. So the next thing you need to find out now is how are we, who are these service providers, right? Next thing is you put down the name of the service provider. So let's say our fictitious service provider is internet owners, internet owners, and they are giving us traffic on, they are giving us internet with their IP on, with their public IP, which is this. So this is internet owners, and then we are getting a second service provider. Let's say network now, and their one is 65.98.52.5, right? And this is the IP they've given us, right? For instance, and these are fictitious IP addresses, right? So these are their public IP addresses that they've used to connect us to the internet, right? And then once we've done that, next thing we're going to try to connect our distribution network to our access network, right? So now to connect our distribution, it's not necessary at this point to know the actual number of links you have to these locations, right? So you might have two links to the internet owners. Just make your diagram. This is just a very basic diagram, right? Make Just put in the one link, just one of the links, and continue. When you've done it to an extent, let's say to an 80%, and the network is looking complete, then you start worrying about redundant links, right? Now, the next thing we have to take a look at is connecting our distribution network to um, our access network, right? So here we're going to connect these. I'm just going to make them one link. Ideally, you would have redundant links to these locations. Right? So let's say that this is what we are looking at the moment of what our various floors look like at the minute, right? So this is what our network currently is looking like. Now, the next thing you need to do, let's quickly connect this NVR so that we'll get that out of the way. Let's say we've had it connected here and we have another connection here, right? So that we can reach all the cameras that we have. So now that we've connected them, next thing we need to take a look at is labeling. We need to label correctly, right? So we've labeled this. This is obviously our LAN. These are LANs. This is our DMZ network. This is our public network. So we need to label appropriately. So you can start by labeling, right? So you can start by labeling your DMZ and give it the IP address. Type the IP address in there. That's what you can do. Now, the IP address is just the network address, right? So that's what you need to do at the moment. So label this and then start using colors to differentiate between your various networks. So let's say we have our ground floor. No, sorry. Let's say we have our ground floor right there. And next we have the first floor. We're going to leave this out because we know that this is also in our first floor, but it's in a different part of the first floor. You can also highlight it with a color if you like and give it whatever tag you want to give it. Now, when we've come to this point, we are at a very good place. Once we've come to this point, we are at a very good place. At this point, all that is left to do is consider redundant links and multiple devices. Now, when I say redundant links, what I mean is if, for instance, internet owners, if we have more than one link from internet owners, then you need to represent that by putting more than one link. Let's say you have a radio link from them and you have a fiber link from them, then you have to put in those to represent that I have such and such links, and then you label them and the individual IP addresses. The same thing for the second service provider, right? The next thing you need to do is come to your distribution section. So the distribution section obviously would be doing VLAN management here. So this is where you start finding out the services, the important services that are running in the various locations, right? So VLAN management, obviously, VLAN management. So this is where you are managing VLANs, you're managing spanning tree protocol, you're managing all of that. And here you can label the various VLAN IDs that exist. So, and all of that. So what we're doing here now is ensuring that all our redundant links are represented and that services that we have that are running on the network are represented as well. So that when someone takes a look at the diagram, they understand what is going on. So um, yeah, that's basically how you start out with your diagram, right? And ensure that everything is looking good. Now, this is a manual approach. This is an approach that you take if you have a small to a medium sized network, right? It's a manual approach and it goes a long way to tell you what is running in the network, right? For instance, if you had multiple access points, you can also represent them by adding the multiple access points because access points will have a static IP address, right? Obviously would have a static IP address that they are managed with. So those devices that have static IP addresses can be represented. So for instance, if you have 4 APs here, you can represent 4 APs by bringing in 4 access points and connecting them to the switch, right? And putting in their specific static IP addresses, right? But devices that run on DHCP, devices like laptops, desktops, tablets, kiosks, and things like that that run on DHCP, don't need you to represent them with a diagram or with an element inside of Packet Tracer or any other diagramming tool that you're using. Those kind of devices don't need you to represent them because they are DHCP devices. They can be changed or removed at any time. So, but the static devices, the printers, the access points, the access control devices that are on the doors, the cameras, things like this that need static IP address should be represented in your diagram. Now we have this almost completed. You can go ahead and populate as much information as you need to populate as you go and ensure that the diagram looks clean as you go along. Now the next thing we're going to be looking at is how you can do this inside of other tools, right? So we're going to be taking a look at how to do this inside of other tools. Now, there are so many tools that you can use to come up with your diagram, like the Cisco DNA Center has a capability to help you to come up with a network diagram. It does its discovery and tells you what is located where, right? But if it's a small to medium sized network that there's no need for a Cisco DNA center, you don't have that, or you don't even have the budget, there are tools that you can use, and I'll be showing you a couple of them. Now, device discovery is something that can be really complicated in networking, especially if it's a new network or you are new in the company and you don't know anything about the network, right? You might not even have people to ask, and there might not be any documentation. You might not have anyone who is experienced enough to know what's going on within the network. That's why you need discovery tools. In some network devices that you would have in your environment would enable you to discover devices around them or within their environment. So if you had Cisco, obviously you can use CDP, Cisco Discovery Protocol, to discover neighbors within your network and document these devices. I think that's what the DNA Center also uses to discover devices within the network, right? Cisco devices within the network. Now, if they're not Cisco devices, you obviously can log in and do something like uh, a scan, use an IP scanner, use all these IP open source tools to scan and try to find the devices. Now, you can also use ZenMap, which is what you have on the screen, right, to scan and find and try to map your, network topology, right? So I would quickly log in here and map my home network. Now, this is not a 5-floor network like we saw in Packet Tracer. This is my home network, and I will try to map it and show you what it looks like, right? It's a very basic network, just a single router and devices that are connected, right? So obviously, within your network, you need to know the IP that is in your network. So my IP address is 192.168. Yeah, that's my IP address right there, right? 1.0/24. That's my local area network IP address. Now, I don't need to do an intent scan. I can do a ping scan, right? Just to ping all the devices around me. Now, if I do this ping scan, and you don't need to use the graphical version of Nmap. If you have Nmap on a Linux box, you can do that as well and use this command right here to scan for devices. So once I do the scan, it's going to start finding devices that exist in my network. So the scan took a while to complete. It scanned and found out that I have a couple of hosts, as you can see on the left. So these are the hosts that exist within my network. It's a pretty basic network, right? Now, to identify what the topology looks like within my network, I'll just navigate to the topology tab. And as you can see, it's going to show me this as my topology. If I try to zoom in, for some reason, zooming in takes a lot of hard work on my end. So as you can see, it's a star topology, right? It's using a star topology at the moment. So this is my gateway device, right? This is my gateway device, and these are all other devices that are within my network, right? So it's going to tell you what kind of devices they are as well. It's going to try to identify what kind of devices you have within your network. If you do an intense scan, or if you do a more in-depth scan, it's going to take a longer time to identify those devices, but it's going to identify them and try to identify what kind of operating system runs on them. That way you can have an idea of what you are documenting or what type of device you are documenting, right? Now, you can also go to host details to try to find out what device that is. So you have this as well. Let's see if we find a couple other devices that have a different. So it's not really going to give you much information as I did a regular ping scan. A ping scan is just going to ping a device and tell you if the device is alive or if the device is, not alive or dead, right? So that's what a ping scan is. If I had done a more in-depth scan, like maybe a TCP scan or a TCP intent scan, TCP ports and or intent scan UDP ports, or these kind of intent scans, I will have more information like operating systems that run within my network. That way I can use it to start to document, know where these various devices are located, and come up with a much more detailed network diagram, right? So you can make use of this one. You can make use of the DNA center if you're in an environment that uses that. You can also go into the devices one after the other, or you can start from your core device, your gateway device, and start running commands like cdp run, show cdp neighbors, and you know start identifying devices that are, around them, or going to the graphical user interface and start identifying, various interfaces that are configured on your device and start documenting them in the diagram. So I hope I have been able to um, help you out understand how you can ask the right questions, start coming up or start designing your diagram, your network diagram, which is really important, or, start at least know the right questions to ask to build out your network diagram. So if you have any questions about how to do this, about, any specific area that you're confused about, just let me know and I'll try my best to get a good answer for you. If these videos have been helping you, please do drop a like, a comment, or, you know, subscribe so that you know when the next video will be coming up. Thank you so much for watching as always, and see you in the next one.